Hi, um, good morning or good afternoon or good evening, fellow classmates and also lecturers who are watching this. So my name is Yiming, and today we have my team, which me is Shalina, and we'll be going through more about our analyzed malware, which is LuckyCat. So for today's contents, we'll be going through some basic information about the malware, the lab setup, followed by the tools used for analysis and what kind of analysis methods we have used to analyze LuckyCat, after which we'll be going through our conclusions and reflections of this project. So now on to some basic information about LuckyCat. As though its name says that it's a lucky cat, it has not made its victims feel very lucky. So LuckyCat is actually an advanced persistent threat that was first discovered by researchers in 2012. And since then, people have actually realized that this malware has been active since 2009, as early as 2009. And then after that, it is also has been attributed for several high-profile cyber attacks, including the 2011 RSA breach and also the 2013 attack on New York Times. So the group behind this malware is actually known for its use of sophisticated zero-day attacks and tactics to compromise target networks and steal sensitive information through the use of LuckyCat. Yeah. So right now, I'll pass over the time to Shalina, who will be sharing more about the lab setup that was used to examine LuckyCat.
So for the lab setup, firstly, our team was using both the Windows 10 and Windows 11 Professional on our local hosts, on our local machines. So for both of our laptops, it was running the virtual machine workstation 16 Pro, which is VMware, and within this VMware, we hosted the Windows 10 Professional, and we installed in the Flare VM tools. So for the host machine, we made use of one Windows 11 Pro machine running on the following processor with 32 GB of memory and the system was a 64-bit operating system. So the other machine that we were using was running a Windows 10 Pro and the following was the processor, and it was running a 16 gig of memories. So next, for the virtual machine, the reason why we use the virtual machine was to ensure that there was isolation between our host machine as well as the machine of where we are running our virtual machine on. So this will help ensure that our device will not be infected with the LuckyCat malware. So for the operating system of the virtual machine, we use the Windows 10 Pro, and we use around 8 GB of memory which is running the 64-bit operating system. So we installed the Flare VM tools, which is compatible with Windows 10 and up virtual machines. So Flare VM is an open source tool which compiles the various software installation scripts for the various tools required by malware analysts. So these scripts will actually aid in the quicker installation for the various tools that are usually used within the malware analysis process. So next, on to our network configuration. For the network configuration of the virtual machine, we use the host only settings. So there are different configurations that we are able to configure, being the bridge, net, host only, as well as the LAN segment. The host only network configuration is used as it is only connected within a private network with the host, which means that the malware will not be able to connect to the internet or will not be able to use another IP address connected to our same internet, ensuring that both our host machine as well as other machines within the network will not get compromised by this malware. So for the tools used, which are web-based, we have VirusTotal, CyberChef, and Text Comparer. So VirusTotal is a tool which allows the users to upload and search for files, URLs, IP addresses, as well as file hashes. It makes use of multiple antivirus engines, which is able to detect if the file or a URL is malicious. So for CyberChef consists of various encryption and data extraction methods. So using this tool, malware analysts are able to detect the algorithms if they are unable to detect. So using their magic tool, and we are also able to make sense of the information that we actually found, which are encrypted by the malware. So for text comparer, the text comparer allows the user to compare the changes between large bodies of text. So in this case, we'll be using it for our string analysis, as string analysis consists of a long list of strings. If we use just a plain iPower, we may miss out some essential changes made by the malware. As such, the text comparer, which helps to highlight the information which is different from the file, will be useful. Next, passing on to Yiming about the tools being used for the basic static analysis.
Thank you, Sharlina. So back onto the tools that we use for basic static analysis, which is actually one of the 4 methods that we use to analyze LuckyCat in this report. So basic static analysis is an analysis method that focuses on using automated tools to understand and also have a starting point of understanding and comprehending what LuckyCat can actually do and its functionality. So let's get into it. So for our first tool, right, we've actually have WinMD5. So WinMD5 is able to calculate the file's hash and is also commonly used to check if any files created by the malware is actually the same as malware. So this point is quite interesting because certain malwares out there, or actually a common trait of some malwares out in the wild, is that they like to duplicate their own malware and rename it as another file on the system. So by using WinMD5, we are able to uncover whether a certain file that's stored on the system is similar to the malware, which is true using the hashing algorithm that WinMD5 provides. So for our next tool, we have PEiD. So what PEiD does is that it can identify the packer of the executable file, and it actually uses a database of signatures to recognize which packer an executable has. So the third function of PEiD is that it also is able to check whether the file is packed or not. So how it does that is that PEiD has 3 different types of scan: normal scan, deep scan, and hardcore scan, which is able to display further details on the malware and also display the raw and virtual size of each section of the portable executable, so that we are able to see whether the executable is indeed packed or just not packed. Yeah. So the next tool that we have, right, is PEview. So PEview actually shows the date and time stamp of when the malware was created, and this actually can be used to create a timeline of events with the other section headers that may contain also the time and date stamp. So this will give you a rough idea of when the malware was created and when the malware author actually wrote out or compiled each and every section of the malware. So next tool that we have is Dependency Walker. So Dependency Walker, what it does is that it shows the imports and exports of the DLL files used by the malware. So what it does is that it helps us to identify some possible functionalities of the malware, perhaps through the identifying common import or export functions that are able to be found on the Microsoft documentation online. Yeah. So for our last tool for basic static analysis, it will be BinText. So BinText, what it does is that it extracts strings from the malware and displays them out for the user to see. So this is a very good way to highlight what strings are important out from the malware and uncover some host or network-based indicators. So what this means is that essentially, BinText can find certain keywords that may appear within the malware. For example, perhaps a URL link, or perhaps showing some changes to the registry keys. So it actually does give us a deeper understanding of what the malware is really truly capable of. And it is a pretty good start in giving certain context in understanding what LuckyCat or whatever malware that you are analyzing, what its functionalities and capabilities are. So now I'll pass the time to Shalina. She'll be talking more about the basic dynamic analysis tools.
So for the process of the basic dynamic analysis, the following tools were used: Process Explorer, Process Monitor, RegShot, ApateDNS, as well as NetCat. So Process Explorer helps to provide the insights on the active and running processes, the various handles, and the data link library files which are running within a certain application. It is also able to view the strings in both the image and memory to view whether there is any changes within the strings that are loaded into the system. So another thing that our Process Explorer is capable of doing is to create and kill processors, and they are able to verify for a legitimate process if it is digitally signed by Microsoft. So next, for Process Monitor, it monitors the changes made by the various processors. It has preset filter values to ensure that you are able to find what are the specific executable that you are trying to find to view the operations for. So allows you to view the registry operation, file operations, the locations of the operation where it's being performed, and as well as the details of the operation performed. And for RegShot, it helps to capture all the configurations set within a specific directory. So it helps to compare the changes made between the two shots. The first shot, which is usually taken before the malware is executed, and the second shot after the malware has been executed. It allows the users to actually output the logs in either plain text form or a HTML document. So this will help the malware analyst view the registry operations that has been done within that specific directory that they have selected. For ApateDNS helps to monitor the DNS connections made out of these systems. So it captures the domains that are actually queried, and based on this information, the malware analyst is able to learn more about which domains are being requested for, and which domains the information may be sent out to. So the ApateDNS allows the users to also configure the DNS reply IP address, and usually the options that is set by malware analyst will be the 127.0.0.1, which is the loopback address for the system. This will allow the analyst to actually view the operations of they'll be able to view the network operations made outbounds from the machine that they are running the malware on. Lastly, for NetCat, NetCat is able to monitor the connections both inbound and outbound, and is able to capture the data sent. So we can learn the information being sent over from this, as well as the information that is actually being accessed by the malware. So using the NetCat command, we can listen. We'll usually listen in for the incoming connection, and we will specify the verbose output as well as the port that we are connecting towards.
So now onto the tools used for more advanced analysis. So firstly, for advanced static analysis, which is the method of analysis by analyzing the source code without running the portable executable, so that you can understand the code and what the functionalities and what the executable is meant to do. So the first tool that was used was IDA. So as you can see on the slide, it's IDA. It's stated that it's IDA Pro, but there's actually a error on the slides. It's IDA free, but despite this, we're still using IDA, so it's still pretty much the same, just with limited functionalities. So firstly, about IDA, it is a disassembler and a debugger. So, but unfortunately, as we are doing static analysis, the debugger functions will not be touched upon during this report, and also during this exploration. And secondly, one feature that I extremely love about IDA is that it has this graphing feature that is able to visualize how the code blocks and also how the program flow of the portable executable is run. And another good thing about IDA is that it enables the users to view the strings and also the hex of the malware code. So if you do need a change between several of these different functions, it's freely found on IDA. So another tool that was used for static analysis was also Cutter. So Cutter is a disassembler and a decompiler. So although it's somewhat similar to IDA, what Cutter was primarily used for in this project was its decompiler features, as it is able to convert and display code so that users can see assembly code that is decompiled into more human readable or higher level language code, so that it's easier for people to understand what the code is trying to do or carry out.
Okay, so for the X32DBG, this X32DBG is built for a 32-bit system. It's mainly used to analyze the code as well as a running of the debugger. So the X64DBG is also available for the 64-bit systems, but as we are analyzing a 32-bit malware, the X32DBG tool is used. So the X32DBG tool is able to decompile files into assembly code, perform debugging, viewing of the graph of the malware, viewing of the registry values, as well as the stack. So this will all be used and analyzed during the process of conducting the advanced dynamic analysis. So next on to our analysis, we'll have the basic analysis of the basic static analysis, followed by the basic dynamic analysis, advanced analysis for the advanced static analysis, as well as the advanced dynamic analysis.
All right. So for basic static analysis, as previously mentioned, what it does is that it helps malware analysts to gain the initial idea and concept of what a certain malware's functions and capabilities are. So the good thing about basic static analysis is that it does not require the analyst to have strong technical knowledge on how to use the tools. However, there needs to be some very basic knowledge in terms of interpreting the results of the tools, which is easy for a lot of people to do. So tools that were used in the basic static analysis segment of this project was BinText, Dependency Walker, WinMD5, PEview, and PEiD, which was also previously mentioned. And all these tools actually assist the analyst in getting more information about the executable. So moving on next.
Okay, so for the basic dynamic analysis, this is usually carried out once the basic static analysis technique has been exhausted. So it requires the analyst to execute the malware and examine the system after the malware execution. It allows the analyst to observe the changes being made by the malware and is more efficient in determining the malware's functionality. So as the execution of the malware is required, we took a snapshot of the virtual machine running the Flare VM tools, and this snapshot included all the tools as well as the malware sample. This will allow the analyst, which is us, to actually roll back the virtual machines to reanalyze the malware when necessary. And the tools that will be used for this basic dynamic analysis will be the Process Explorer, Process Monitor, RegShot, ApateDNS, as well as NetCat. So this will assist us in capturing any modification or creation of the process or activities within the system.
So next up, we have the advanced static analysis. So this method of analysis is used when basic static and basic static and basic dynamic analysis is exhausted. So this analysis method is understanding the malware's code on a assembly code level. So it's closer towards the code that is used to instruct the machines and our computers on what instruction needs to be done. So this analysis actually provides more in-depth analysis as compared to the basic static and basic dynamic analysis. However, there is a prerequisite of having the need of having a strong background in assembly code to understand the code that the malware author has coded out. Unlike dynamic analysis to advanced static analysis does not require any previous like setup or any sort of snapshot to take of the VM as the program is not run. Firstly, we are analyzing the malware by using the disassemblers and decompiler function of the tools that were mentioned previously, and these tools actually allow the malware analyst to read the assembly code that is stored within the malware's code, and also using the decompiler function of certain tools that was previously mentioned is also we are also able to generate pseudocode so that the assembly code is slightly more human readable and also understandable for easier for the malware analyst to understand the code and its function. So an advanced static analysis also enables the malware analysts to identify the general behaviors of the malware and gain a deeper understanding of the malware's intentions. So as previously mentioned, the advanced static analysis tools are IDA-free and also Cutter, which each have their own benefits and functions that were used within this project. So for IDA-free was mainly for viewing the assembly code and using the graph view of IDA-free so that we can understand the program flow. And for Cutter, it was used to decompile the assembly code so that certain assembly code that was more obfuscated and also a bit more hard to understand, Cutter was able to translate all these assembly code into a higher level programming language code so that it was easier for the analyst to analyze the code and understand the malware's functions.
So for advanced dynamic analysis, the analyzing of the malware will be done through the debugging as well as reading of assembly code. So this will enable the malware analyst to identify the complete process of the malware's operation and better analyze the malware. It also provides a better understanding of the malware's intention compared to the basic static as well as the basic dynamic analysis. And the tool that is being used for advanced dynamic analysis will be X32DBG, which will assist in the debugging, the viewing, and will be used for helping to break points and to analyze the code slowly. So this operation and any operations occurring to the system during the execution of the malware will also be seen using the debugger.